Hello, everybody. How are we today? So, like I said last week, we're going to do something a little bit more interesting, a little bit different to the Python editing. Still thinking as a coder, looking a little bit of electronics, robotics, things that really do excite me. I've always been into making my own robots, and now it's never been easier, and lots of different tools as well to do that, including things like vision AI to locate objects and track objects. Things are really interesting in this space. So we're going to get cracking straight away with some examples and some ways in which you can tinker around without actually having to own some robotic kit or electronics yet, but something you may want to do. So if I have a little look at the screen here, camera screen. So what you can do, or some of the things that you can do is, again, to follow us on the Thinking as a Coder website that we have here, because there's some links that are easier to click than try and remember, is just go to digital.edu.je. That's the site that we have to have everything in. And like I said, do make comments and suggestions if there are types of electronics or robotics you're more interested in. I'll try and incorporate those as the weeks go on. But today is very much an introduction to how we could get going to make our first little robot. And a couple of things that I like to do straight away is make these kind of robot wars type solutions. And, how can we make things attack other things and move towards them and things like that. So like I say, go to digital.edu.je. And when you're there, you can go to the Coder page here, and there's a couple of different links. We're kind of there's lots more on our repository now that we're building up the different sites that we can use to go forward. And one of those things that we're having a look at here is we've got the Make Code editor that we'll be using today, but I also want us to look at something called Tinkercad. And Tinkercad can do many different things. And if I click on this one today, we're going to look at the Tinkercad electronics section. You can also make 3D design for 3D printing, something else I really like. And you can see from this intro, there is a microbit that it's talking about here, which has this drag and drop situations. And we can add 3D printed devices and really play around with this. So it's really, really good site. You do, however, need an account to create for one, and I'll show you different ways you can do that. But it's very, very similar, and we may have a little look as well at the Make Code area as well. So the two main areas I go for robotics are the Make Code, not the Python editor today. It's easier to use the drag and drop for some of the electronics parts and the libraries that we need. But we're going to have a look at the Tinkercad electronics to do that. And when you come to log into this page, I think I'll just zoom in a little bit so we can see a little bit better today. When I click to go on that, you can have an Educators account, and some people may have school accounts to go with this. But what we also do is we can go to personal accounts or join Tinkercad. So again, you would need to create a personal account, and you would need to go through maybe with a Google account or sign up with an email. So you'd need to go through that process and have your parents' permission if under the age of 13. But the easiest way for me is to use my Google account because I'm already signed in with Google. Most people have it, and you're probably already signed into Google to make comments on the YouTube chat anyway. So if you do have a Google account already, you can click on that and probably go through some questions and answers and some processes while it checks who you are. Now, again, you'd need a parent to sign you up for this, because if you go for an age which is under, and I'll just come off, you don't need to know quite how old I am, maybe today. If you're under 13, I believe you need a parental permission for this. So any age under the age of 13 will probably do a rejection of that account. I should have double checked that before I started today, but it was only when I came to make that account that it's there. Now I'm signed in with Google, and you still need to create an account for Autodesk, which is the makers of this site as well, and that just requires you to have your own name. I think I probably already have that name selected. I'm signing with the Google, LinkedIn with the account, or I can skip. So you may not want to create a new account with a new provider. In fact, I'm not going to myself, so I can just use that skip option and just say, you've got my Google details. That's enough for now. I'm going to click the skip to go through to it. Then continue. So it may take you a little while to go through that process, but you'll come into Tinkercad. And this is where we'll see there's lots of different areas for Tinkercad. We were on the circuits when we first came in, but there is also this 3D design option here to make our first 3D design, or some lessons here if you want to do this on your own and go through that. Or we have these circuits or code blocks, which is kind of like a bit of coding design to make things quicker, make repetitive designs really, really easily. But we're going to go into circuits today. And again, if you were, now I'm signed in, if I was actually to click that link, it would probably go straight into the circuit design if I do start tinkering. And it still takes you to this home screen. It used to take you directly in. Must have been a change since the last time I've been here. So there are different things that you can play around with, different circuits that are all ready to go. But I'm going to go from scratch, and I'll be here to be your guide for this. So we can click on create your first circuit. I can see a couple more people have joined the stream. So just once again, a reminder that we go to digital.edu.je. You would need to go to Tinkercad here to go into the Tinkercad circuits option, and you'd need to create an account or sign in with Google. Just a little refresh for any new joiners there. So we click on create your first circuit design, and it will take you to this area where you can play around with any electronics that they have on file for free. And it says here, as we've been using, we've got the microbit controller. So I will take a note of my face that's there, but I'll try and only do things in the top section here. But you can scroll through, and like with the microbit that's there, you can scroll through to lots of different things, including an Arduino Uno, which is another type of device, and all these other kind of bits and bobs. It's quite good to have a little scroll through, and that's on the basics tab that's at the top here. We'll be able to go through Arduino starter pack. There's an Arduino one, and it's got some radios, some servos. We're going to do this ourselves and show you how to do that, but there are different areas that we can have a look at, all parts and starters as well, looking at different things that, when you've got enough time, you can go through and have a little bit of a play with. But we're going to go and just have a look at the basic starters kit that's here, and we're going to go through and not the basic starters, we're going to go to the not the starters kit, just the basic components, slightly different there. I don't want the starters, I just want all the bits and pieces. And again, we could go to all to have all of the components that are available, from distance sensors here, ultrasonic sensors, to lots of different electronics parts. It'll even let you play around with a potato and a lemon battery, which I think is quite interesting there, as well as solar power, something that we can use. So loads of different options to have a go here. If you click all, I'm just going to have a look at the basic components here. And there's lots of things that we can learn. Now, if you get excited about this, we talked about this before, there are lots of electronic starter kits. And if you go to things like Amazon, you can pick up these starter kits, including microbits. I quite like a website called Pimroni, and that's quite a good site, Raspberry Pi site, and other electronic sites that you can use. And you can start to search around for stuff. They ship to Jersey. They take VAT off, or GST off, which is quite useful. Your parents will know all about that. And you can do electronics kit maybe, and it will there go to electronic kit for Pico, for microbit. There's lots of little starter packs for quite a small amount of money, I think, as well as quite a large amount of money as well, that you can really get to grips with your microbits. So for right now, though, we can come to tinkercad.com/circuits to play around with these devices. So let's get started. And if you've had time now to load up this page, do try and do this along with me, or just listen and watch and maybe do it in your own time. So the very first thing I'm going to do is not play around with a microbit just yet. I'm going to come in and I'm going to have a look at some really basic things. And I'm not going to look at a 9-volt battery. It's a bit too much for me right now. But I am going to look at a 3-volt coin cell battery. They're just these tiny little batteries. You may have seen them in computers or something at your house. And when I click on that, it will come in, and I click again and I can leave it there. I can move it around if I want to. But here we have our coin battery. I could have done a 1.5 volt battery, but I'm going to use a device that needs at least 3 volts. And we're going to start to talk, not today too much detail about voltage and resistance, but we are going to look at some easy ways to get started quickly. So we're going to look at that coin battery. And we're going to drag in an LED as well here. So the coin battery was there just above my head, 3 down there. And the LED is one of the first things that you can see. And I'm just going to drag it in anywhere at the moment. You can change the color if you want to. It's not really a big deal at the moment, although later on when we come to deal with electronics properly, we can sometimes see that the light does make a difference to resistance, but let's not get bogged down in that right now. The next thing that we can do is I'm going to deliberately join these up in the wrong direction. Now, this is a place where you can get really stuck really quickly. When you're on tinkercad.com/circuits in this example, if I was to click at the end here to join this up to this battery, I can click and then I can click again on the ends. But if I accidentally, and I'll try and zoom in a little bit more on this so we can see a bit more clearly here, you can see that it's kind of flashing around, it's having a look. It wants to join to that, and it says anode and cathode. And if I click somewhere else other than that, it will just keep clicking around until I come to the end. And if I don't like it, I can press the delete or the backspace key to get rid of it. But if you're clicking around and go, oh, it's stuck, I'm getting confused what to do, you just need to end it. You can end it where it began sometimes, but it doesn't like to, so it's not going to let me, or the other end of that, and just press delete. But it won't stop moving around until you stop it at the end of another kind of point as such. So I'm going to do this wrong to show you what might happen. So I'm going to go to the negative here, which is, it says negative and it's black and red here. And I click on that negative and I'm going to move it. And if I move it around, you can see that it's trying to draw straight. If I let it, it's trying to draw straight there. But I'm going to get this slightly wrong to show you something else you can do. And I'm just going to join it to this little kink here that says anode. This is wrong, and I'll show you why it's wrong in a minute. I'm going to click it there, and then I'm going to click on this positive and go to the cathode. Now, this is a mess already. Not only is this wrong, because I can do start simulation now, and it will try and activate this circuit, and nothing happens. Nothing is happening because I've joined up these lines, or these positive and negative, to the wrong side. So when you press start simulation, if it starts this timer at the top and nothing happens as expected, it is likely that you've just got something wrong. So I'm going to stop the simulation. I'm going to delete both of these things. So the first thing that we need to know about electronics, and like I said, I've seen a few new people come into the feed right now. So if you're not up to speed, remember to go to digitaljersey.edu.je. And today we're clicking on Tinkercad, and it's taking us to Tinkercad circuits. And we just created, or we logged in using Google, and we're ready to start. So I need to join up the negative to the negative and the positive to the positive. Otherwise, it won't work. And the anode is the one that I need to join up to the positive here. Now, the way I remember this isn't the greatest way in the world. But if you were to draw negative and positive symbols, so if I was to draw a negative symbol as just a line, and then I was to draw a positive symbol, as best I can do right now. I know it's the number 4, but a positive, which takes the most amount of kind of cable or ink to draw? Well, the positive takes the longest amount, and that's why it's the longest leg. I know it's a terrible way of remembering it, but it's the positive leg is the longest leg. And if you had a physical LED, and next time I'll do this, I'm going to get a camera. I've got one sorted out ready for me. I'm going to point it down at the desk, and I'm going to build this physically to show you that this is a thing. But we're going to do this virtually for the moment. So the positive needs to join to the longest leg, which is the anode there. Next, the negative goes to the shortest leg, which is the cathode. Now, this will work now when I press start. There you go, lights on. It's also going to come up with an exclamation mark, though. It's saying that 3 volts is kind of okay, but it's a bit too much, and I'm going to reduce the lifetime of my LED light. It's not the optimal amount of voltage. It's a little bit too much. It will work, but it's not going to last forever. And that's what we're going to talk about resistors, possibly not today, but at other times, to reduce that current and make these things work and not get exclamation marks. But today is more about just creating circuits, making things work, and getting it forward. So one of the things I don't like about this is my green cables here. I'm going to click on the green cable at the top, the positive one, the one that's joined to the red dot here, and I can actually change the line or the code here, and we've got wire color red. So now that's positive, and I should do the negative black. That's standard colors for my negative and positive. The other thing I don't like about this is that, zoomed out a little bit there, is that it's not neat. Okay, so I can move this around when I've stopped the simulation. It doesn't like you moving things when you've started the simulation. I'm going to move this around, and I could make that leg straight, the red one straighter. That's all right. But the black negative here, I can click anywhere along here in the middle, and what I can end up doing is deleting it possibly and just getting those lines sorted. Now, in certain other programs, and I will double check that this one isn't the case, when you've pressed that click, sometimes they allowed you to add another node or something like that by right clicking. This one, there you go, double clicking, there it is. I thought it did have this. So I'll just do that again. Click once, nothing, double tap. Oh, there you go, or tap and hold. There was one of it there, or right click. There you go, double tap on the right click. That was a bit weird. But if you can't get that working, just delete it and try and manually join them up like that. Looks a bit neater. So different ways in which you can do that. Again, I'm going to double tap the right click, maybe different on different computers. No, not working on double tap, right click and hold. Double tap on there. It's working on a double tap, but very temperamental on my machine right now. So different ways you can do that. The easiest way is to plan ahead and just kind of draw them as you get round to them. And you see here, if I've not done it straight, I can just move that up. So again, I've spent a little bit of time doing that, but being neat with these circuits straight away is a very useful thing to do. And you can zoom in, zoom out as you go with these. So we've made a light do something. That's about it. We can start to use other devices and other tools here to have a go. And we could add things like a button. So I'm going to get rid of my negative symbol here, come to the top of my components list, and I could click a push button and drag it in. Now, this may seem a little bit odd when I come and do this, but you need to know which of these kind of work and which ones don't with your buttons. And it's kind of the opposite as I'm going through here. So when I'm joining this up, I can join this negative to this corner here. I can join this corner to this corner, and now when I press my button, the light comes on. There you go, I'm pressing my button, the light goes on. We're making circuits, we're making things easy. So this is great to play around with different devices. If I was to get rid of everything, or start clicking away and getting rid of things, I could drag in motors. I could drag in a 3-volt motor, negative to negative, so I've got the black to the black there, positive to positive. Might want to change the color on that, but let's just start the simulation. And it's going quite slowly. Now, it's going slowly because I'm only using 3 volts. And this DC motor that was behind my head there requires a little bit more electricity. So I could get rid of that, come to my 9-volt battery, slightly bigger there, and I've got a negative to a negative, positive to a positive, a bit of a crossover there. I might want to click on my icons and get them to, if I do that double clicking, it's not liking when I'm doing that double clicking very well, so I'll just do this manually. There you go, it's got my straighter edge there, and I might do the same for that just to make it a bit neater. And when I do this now and press the start simulation, it's going to go much faster because it has more voltage. And we can start putting things in like potentiometers and different other things to control or toggle and spin around with that. So have a play with things that are here. We've got hobby motors, vibration motors, different things, and we're going to try and go through those over the course of the next few weeks to do a bit of electronics to see how we go. So as I come out of this one of the other things that's useful to know is we do have these twisty buttons here and flipping buttons. So I can reduce or twist that round if I don't want to see the whole icon here. And then I could do positive to positive, negative to negative. And that, maybe looks a bit better if I was to do it a bit more like that. There we go. Well, we are where we're at. And we can then make certain things different colors to make it more obvious. And we can try and use extra nodes wherever we want. So we've got the basic electronics that we have there. Now, what I would say to this one now is, well, let's have a go at something more codey. We've done basic electronics. Can we get the object to do things? So if we actually drag in a micro bit here, and I zoom out a tiny bit, this micro bit is currently not plugged in. And if I start the simulation now, we've got the idea that it's done a program. Now it's got a smiley face on here. And if it's got that smiley face, it's because there must be a program. So I'm going to stop the simulation, otherwise it won't let me edit anything here. And I'm going to go and look at this code button that's there. So I press the code button and it shows me that on start, it's going to show this happy icon. And again, we can zoom in, zoom out and see what we're doing. And we've got a very similar setup to what we had when we were in the make code, thinking as a coder area. If I log into that the other week, I was doing my blocks here. And it's a very similar lookout. So this allows you to do lots of different things, but for the sake of today, we've got enough here, but it might look slightly different when we come to do stuff. So if I want to do the blink, I don't want that. I can drag it out or put it in the bin that's just hidden by my head here. In fact, I might just move this to the side slightly here so I know that I'm not getting in the way of anything. There we go. And when I was dealing with that, I got rid of the on start, and maybe I want to do blink, and I can do this show icon in forever. Just press minus a little bit for that. And then I'm going to do the wait, which I have a look at basics. I've got all these different ideas here. I've got output and my show number, show string. So things are in slightly different positions and you have to kind of have a look through and find where they are. It may be maths and it may be control. And then we've got on control, we've got the wait 1 second. We can go back to basic and do that kind of nothing screen that we've used before. I'm going to trash this on start because I'm not going to use it anymore. And I'm also going to go to control and bring in another wait at the bottom. Now, when I press start the simulation here, we can see that it's got the happy face and it's blinking as I go. It won't let me change anything until I stop the simulation. Maybe I want to go to the heart this time, start it again, and I've got my blinking heart. Now, the reason why I'm using this Tinkercad circuits today is because it has more options to do with the electronics. If I went into the make code, the only real electronics that I can bring in is a servo. And if I click on the code icon again here, it disappears to the side. And we can see now that we've got things like micro server. And while I can use that to move things around, I've got more options here for more electronics. Light sensor, soil moisture sensor, movement sensor, temperature sensor, loads more electronics to play around with. And if I go to all in the components there's even more things to play around with. Force sensors there, quite interesting, tilt sensors, LED lights that I can make any color that I want, light bulbs, NeoPixels, lots of things that we're going to get to over the course of these next sessions. And like I said, with some bizarre things like the potato battery. We'll talk about breadboards and if we need them or not, but we can also have things like microchips and some quite complex things, but we may not get to all of those. So today I'm just going to come in and go back to the basic components because that's what we're dealing with here. Let's see if we can start to make things move and make things blink. So I'm going to just delete this server at the moment and come to my LED light. And when we look at the micro bit here, what we're looking at is, well, what's the negative? Now, another name for negative is ground. So here, that ground icon there is something that I can click, and I'm going to click a couple of different times because I know where I'm going, and the ground or the negative goes to that cathode, the shortest leg. So I'm just going to move that, make it slightly straighter. There we go. So the ground, shortest leg, and because it's negative, it's going to be black. But just for the moment, I'm just going to go to the 3 volts, which is the power. We said we like 3 volts for these. I'm going to click it, and click it. That's why I didn't change the color yet, because it was going to go black again. So I'm going to change that. There we go. I'm going to click on this one, move it around. I have a neat little circuit. And because I don't need any code, because this 3 volts is going into the ground, then I can just press start simulation. And we've got the device working. Now, it still had, if I go to the code, it still had this blinking heart. I'm not too bothered about that, if I'm being honest, but we might get rid of that in a moment. It's still saying that I've got slightly too much current or voltage coming to my micro bit, but for the moment, while we're dealing with just making things work and the code, not too fussed with that at all. So let's try and stop the simulation, and I don't want this light to be just on all the time. I want to kind of make a traffic light situation. So I'm going to click on a couple of extra LEDs. I'm going to go red. I'm going to change this one to orange. And I'm going to change this one to green. Okay, so I'm going to make a traffic light situation here. Now, what you can do, and it may seem odd, but we can connect all of our negatives to the same ground here. So I've connected that one, and I've connected the other short one using the black cables. I could get a bit picky on whether or not that's exactly straight. But what I'm going to do this time for the legs here is I'm going to join them to these 3 pins, 0, 1, and 2. So I'm going to go now to red. Oh, it changes the letter, so I'm going to keep it a black for the minute and change it in a second. And I'm going to come in and I'm going to click, click, and click. Now, this is where you don't have to use the colors we suggested. I am going to use red for this option. But when I come into number 1, I'm going to come in, I'm going to click, just to keep things neat. I'm going to click over here. It doesn't have to be perfect. Now, I could keep these all as red because these are going to be the positive versions of this. So in we go, positive, positive, positive. I could potentially kind of straighten them up and stuff, but we've got what we need. If I press start simulation, there's nothing going on because there's no code that I've got to program these. At the moment, there is no power going through these pins. So I need to activate them. So this is where we start to need the code, but this is where you might also, when we do things like breadboards and different jumper leads, I might actually want to color this one orange. I might want to color this one green, just so I know which one's which. You don't have to do that. This is personal preference now. Or you might want to keep them red because you know that they're positive. No right or wrong answers here. I'm just doing this because, so I'm getting really picky on the neatness of that. It seems to bug me. If it's getting really bad, I can move that up a little. I'm getting carried away with it. So what we're going to do now is have a little look and see if I can make these blink in different ways. So I'm just going to stretch out this code again. I'm going to stick the code, I'm going to click on the code icon so I can see them. I might move or zoom this out again because I don't need to be too zoomed in on this one now that I'm seeing everything, and I can click in a bit of blank space to move it to one side. So there's different ways in which you can do this to make it a bit more obvious. Now I'm not bothered about these anymore, so I can move them to the side or move them to the trash. And I want to start making these do something. So let's take it one at a time. So when we've got the basic options, we can have a look, which is showing us pictures that we can draw. We've got different ideas here, but we don't have anything to do with it. It's on pin pressed, but I can't see anything. We have output, clear screen, LEDs, show screens, show. This is the one I want. This is called digital write pin, and there's different options here. We've got rotate servo, we're going to come to different areas, but I want digital write pin, which is found in the output section here. And when I go to digital write pin, I'm just going to stick that to high. Now let's see what happens here. If I start the simulation, this first pin that was on 0, this first red light, is on. So that's pin 0 because it's on the red light. I could stop my simulation now, and I could drag another one in and another one and change that to 1 and change that to 2, and then press start to check that I can start all my different LEDs. Now you might say, well, hang on, I'm just going to stop the simulation here, drag that out and start it again. This one had an exclamation mark saying the current is 20.3 when the maximum is 20. But when let's see if it does the undo button actually. There you go, got an undo button. See if it will bring them back or redo. No, I didn't like it. I'm just going to manually drag these pins back in again. The eagle-eyed among you will have spotted that when I pressed play this time or started the simulation, it didn't have the exclamation mark. And that is because when I'm using all three of these LEDs together, it's drawing that little bit extra power away, and that has meant they're all safe in a way. So I will damage my red LED if I only have that one on. But this shows you that when we are dealing with electronics, we have to think of lots of different things. And the more things that we connect, the more power we require. And we may need a separate power supply. Nothing I'm going to deal with today, but something we may well deal with in the future. And when you come to do robotics and things like that, it is absolutely something we need to consider, but not for today. But let's see if we can use some extra variables, because I don't want these to come on at the same time. I kind of want them to run through a loop, a forever loop that I have here. I might go to control, and I might go to wait 1 second. Then I'm going to duplicate, but it tries to duplicate everything. So I'm going to drag in. It can be a bit annoying to use the duplicate key. I'm going to go back to control. What's hidden over there, actually? I'm just going to drag this to the side. What's happened there is all this area has gone off to the side slightly, and I can't quite grab it. So I'm going to move this out. There you go. So this may happen to you. It didn't delete because I didn't drag it far enough away, although it does seem to have deleted a little bit. I'll see if that code is, it's all shaded out, so it shouldn't matter. And I'll just have to deal with that. It's definitely not like it. I don't really want to refresh the page because it may well go everywhere. It's pretending like it wants to work, but it's not having a good time. It really has frozen. I may have to repeat that. I'm going to give it one more chance to do that before I refresh this page. So let's have a look if I'm going to have to build anything. Hopefully not, or all changes saved. So I should be okay. Because I did use Tinkercad back in the day. It used to be good. We're all good. So I'm going to go back to the code and see where we're at. Oh, didn't like it. I think it was this part it didn't like. See if I can now go in. Yep, that's good. So sometimes a refresh in Tinkercad will take you where you need to be and sort stuff out. So I had lots of things all over the place. A good refresh will take care of that. So here we are. We've got our wait 1 second, and I'm going to drag those in to a little bit. So I'm dragging, I'm going to wait 1 second between each point. So when I press play now, and I move this off to the side, see if you can guess what might happen in your brain. Digital in, wait, digital in. Have a look. Hopefully you thought that this was on. It was like a sequence. But I didn't want that to happen. That would be a crash if that was an actual traffic light. So what I want to do is actually put in some different tools there. So I'm going to say, actually, let's go back to output, and where I saw the digital right pin high, which means on, I'm going to drag it in just before, and I'm going to switch it to low, which means off. So that, and I'm going to do exactly the same thing here, which is going to drag pin 1 actually, because I want 1 to switch off. And then when I press play, it's going to go on, wait, on, wait, on, wait. Okay. And it's looping through forever and not doing what it's supposed to do now because I forgot to switch this off at the end. So I need to check that as I scroll here, when I wait at the end before it loops back round, I need to make sure that pin 2 is switched off. So you do these tests, we do these demonstrations to work it out. And I see a few new people have followed and joined today. So if you have joined late, don't be worried. Just watch what I'm doing and watch at the beginning and see if you want to follow along when I'm done. So we now have our rotating round area. Now, one thing I didn't do, well, I did wrong here, as I can see now, is the amber light isn't going off because I didn't click this to low. I did low, high, low, high. So we go through, and this is what testing is about. And in the Thinking as a Coder exam, you'll be talking about, or you talk about testing. So, you do things quick, you make mistakes, you test these out. Now I've got to a position that's actually quite good, and I like this. We're getting through with it. But that's not how it works, is it? It goes to green, and does it go that way round all the time? Maybe, maybe not. And we wait longer, wait shorter. And we could maybe have distance sensors for this, because maybe we've got a sensor or a traffic light that sees traffic coming towards it. It sees different things, works differently if it's wet or if it's higher temperature. There's lots of different things that we could do to affect how this works. Or we could start to do triggers that activate this, because right now, this is just looping around forever and ever. And this might be actually what we do. And maybe rather than 1 second here, we do a 5 seconds, and we do a 5 seconds here, stopping the simulation. And when I press start, it's red for a little while, and it only quickly goes through the amber and then go, right? So it's telling you to get ready, then it's go. Then it goes straight to stop. Or is that the way the traffic lights work? Well, they don't actually. The traffic lights work by going straight from green, from stop to go, but you have a warning. When you're going, you have that warning, the amber light, before you get to red to tell people you should stop if it's safe. But, if you're hitting the light, you can go through it. Okay, so there's a point. Many people go through amber lights too late. So it's actually the opposite way around. Now, rather than change my code here, I could be sneaky, and I could actually go to these LEDs and change my red to green and my green to red. You can think differently, right? That saves me changing all my code around. So it goes green. It's go, go, go. Then there's a warning that you're amber, and then goes to red. Now, quite often, actually, the green stays on until the next stage. So we stop again and we think about that. The green's on. It doesn't go off yet. It actually, and sometimes I have to drag this out to drag this back in. I'm going to be careful. There's one underneath there. So what we've got there is the green light goes on, but the amber goes on, and then they both, or everything, changes at this stage. So let's press play, green, and then green and amber is going to be on to warn you that you should stop. Then it goes to red. Now, maybe that seemed like a bit of a short warning, so we go to 2, and this is how we play around. And it is someone's job somewhere in the world to plan all the traffic lights around town to see if they behave in a certain way, if they affect the traffic, because it's terrible. If one light goes on and the other is at red, it might just cause traffic. And that traffic flow and that traffic organization is actually a job and a model that we can play around with. But I feel that we've kind of got to where we need to be as a model here, but we might want to put sensors in to do this. Now, I'm going to kind of make this up. I'm going to stop this and I'm going to zoom out a little bit, and instead of having on this control on, start, or forever or something like that, we can actually go to things like create a variable. We've got math, we've got input, we've got output. We can have things like on button A or on shake or on something else happening all the way through all of these. So let's do a motion sensor for the minute. I'm only got 5 minutes to go, and we can talk about all the different things I can do later. And if I hide the code, we don't see it here, but in the all section here, we have an ultrasonic distance sensor, and that will be able to sense things coming towards it. And there are actually kind of cameras next time you look at a traffic camera, but they're actually not kind of movement sensors. They're actually sensors that look at or there's sensors in the ground as well that say if an object is coming across them. Okay, so if it doesn't see something in the distance or a metal object going across, there's lines in the kind of floor. You see them next. You come at a traffic light, you might see a fine black line where there's some coiled sensors to see if a metal object is going across there. But we could just use an ultrasonic distance sensor to sense if an object is coming towards it. But for the sake of today, rather than doing this, I'm going to drag that out and say on pin A or on shake. In fact, I'll use the on shake as it's some sort of external event. And I'm going to say that it's going to change the lights only when this happens. So what I'm going to say here is we've got P value to high. So what we could say is by default forever, maybe, or maybe not forever, drag that out, maybe come to on basic, we've got, was it on control? On start. On start, we could say on the outputs, go to digital write, and I could say send everything to low except the red light, which is on pin 2. So pin 2 to high, everything else on low. And what that means is when I press play now, it's always going to be red forever. Right, forever, until I do shake, which you can press a button here, which is that one there, which is just there. Press that, shake, and then it goes through the system. But the red was still on, right? So what I had to do, we have to change these, because what it said was on start, so let's start the simulation again, it's always red, but when I press this shake here, all it said is turn the green light on. It didn't switch this off. So this is when we test. While this worked for our loop, we need to go in and actually, on shake, we need to make sure all the other lights, no matter what else is happening in our life here, that all the other lights are switched off. Low, low, low. So pin 2, pin 1, and it's just the green light, which now changes. So we press start. We've got the red light forever. We click the shake, and now it goes through the 5 second wait, the 2 second wait. There we go. Works. And this is the kind of thing that happens. So I do believe, and maybe someone could comment if their parents know this, I do believe there is a button in the hospital that when the ambulance comes up, they press it and it sends the light next to the hospital straight to green, no matter what's going on, or at least does the amber and off and sets all them right, so that the ambulance can come through and get straight out. So there's a little signal, I believe. It looks like an aerial on a couple of the lights, and I believe that that's for when an emergency happens. They can click the button and they can click through to go with it. So those kind of things might happen where there may be a button which immediately, no matter what happens with this simulation, if the light was on red, there may be a button they press and it automatically sends it to green or does the amber all the way down. So we can talk and we can have a look at that next session. Hopefully people are enjoying looking at the electronics and looking at the code and the microbit. And what I'd like to do is throw in way more devices next week. What I'd probably do as well is not just show you this virtually, I will also grab all my bits and bobs because I've got loads of distance sensors here. We use them quite a lot of the time. I had to do that there. Got the camera, it's going to be out of focus when I do it there, but there's that distance sensor. And I've got loads of other devices, including the micro bits, and I can actually show you as I go ahead. So there's lots of different tools. And as I said, if electronics is something that's exciting to you, there's a lot of quite cheap starter kits either on Amazon or, like I said Pimroni, which I like, which is there. And you may want to follow along with some of these kind of electronic parts. But in the meantime, you can go to Tinkercad, you can try this out, and as you're saying here, we can do things more complex things like NeoPixels. We can come in to have a look at lights. If I go to all components, gas sensors, LED lights, these kind of ring lights, NeoPixels, NeoStrips. I've got lights next door in the office here, lots of colored lights and strips that do those, as well as the hobby gear motor here, which allows us to make devices, as well as this pre-made thing that you can buy called the Move camera, where we can control servos to make this go. And if I delve down just out of the microphone, I think I do somewhere, I believe, yes, here we go, have my other devices where here's the gear motor that you can kind of see there, the yellow one that's just at the top here, as well as the wheels and devices that we can use the microbit to control this, as well as a distance sensor that goes at the front and tells it how to move along. And there's loads of ways we can do that. So hopefully this is the kind of thing. I was hoping to possibly in the summer see if there was enough interest for like a digital magazine where you could sign up for it and we could send you each month or each 2 weekly the next part of the project, and we could start to build this one by one. And do mention in the comments if that's of interest to you, getting all the way up there. And I do a lot of laser cut printing where I could laser cut parts for us to start building lots of different devices and lots of different robotics at relatively cheap amounts. So if that's something you want to kind of discuss with your parent, or one of your parents wants to sponsor that, then we could potentially roll that out for people to do a lovely bit of electronics here as part of the Thinking as a Coder. As I mentioned last week, we're going to be contacting the schools to say that if you have been following Digital Jersey's website, do like and subscribe. Don't have to type it in. I can go quick to the live link here. And on the live link, we can come in, and if you've gone through these Thinking as a Coders, what I'm going to be doing is sending out ways in which we can test our knowledge on this, and that we can actually then start to look to see if we can do, or people want to do, those qualifications or get that Thinking as a Coder. So we'll continue with a bit of electronics for the moment, and I will send out that information. And like I said, do put in the comments or talk to your parents about whether or not you think a kind of live making session where you can send you kit in the kind of like monthly magazine or bi-weekly magazine is something of interest. So thank you very much for everything. Thank you for listening. We'll continue with this, and I'll get the camera on us next week pointing down, and I'll show you me physically building it as well as doing it online on this circuit diagram, so that you can kind of play along with it. And it'll be quite interesting to see if you can build either virtually or we can start to build physically with these devices. So I'll stop waffling on now. Like and subscribe. See you next week at 4 o'clock. Thank you very much. Bye for now.